Hi, this is Rick. Let's take a look at functions. Now you're going to hear these called functions and modules and subroutines and a lot of different things, but they all are basically the same thing. It's just depending on where we get them. Here are the topics for the day. We're going to introduce functions and tell you how to do that by giving you an example of generating random numbers. Then we're going to talk about writing your own functions, which is fairly easy. Then we'll talk about more library functions, and you'll see that's where the versatility of languages comes in. So as we start, we want to differentiate between functions and modules. Basically, modules are also called procedures or subroutines, and they break down into two different categories. There's functions. Functions are external library things. They're available to everybody, and usually someone comes up with a great way to take the square root of something. Let's say it's a math function, and they put it in a library called CMath or something like that, and then when you actually need it, you can draw upon their functionality. It's usually written by somebody else, and they're usually on the web, and we'll talk about where they are. They usually return a value. So if you took a square root of a number, then that square root would actually return itself to the main, so it could be used by something else. Modules, however, are usually written by you. They're internal to the program, and the nice thing about that is they're totally customizable. They go along exactly with what you want to have done, and they don't have to return a value. They can actually do something like print a whole page. If someone if someone has that option in the menu, they can print the ledger out or whatever you want to do, and then come back and not have to return any value. Introduction to functions. A function is a module that returns a value back to the part of the program that called it. So many languages have them, and we're going to use what is called a random number generator as an example. And the main reason for that is because computers can never randomly generate a number. So a function like that, a function is like a module, but it returns a value. So if that returns a value, then that's what we would call it. So a function library might be one of our pound include IO streams that we've already seen in C++. So a random number function is useful, especially in gaming programs. For example, you can randomly generate a certain figure. In simulation games where you've got the element of chance involved, and statistical programs. The computer security program is also an encryption issue, which relies somewhat on a random number generator. So let's figure out how that random function works, because somebody had to in the very beginning. So we're going to say that random, the number equals random between 1 and 100, so it can pick any number that it would like between 1 and 100. Now, 1 and 100 define the range of that number that can be returned, and are called arguments. Of course, we've learned that before. Now, the function is called, and a random number is returned and assigned to a variable number in that program. Now, that means that the random number is going to be selected on some kind of basis. Most of the time, a random number is not based on a range of 1 to 100, but it may be based on the time of the function that's running right now. So it may be the machine time or something like that. So if random numbers is one of those functions, how can you get a hold of those libraries that contain hundreds and hundreds of functions? Well, first of all, you can write your own. That's easy. Or you can go to sites like these three. Now, this is simply for C++. If you're actually programming in Java, there are going to be libraries out there. In fact, there's going to be a lot of code for that out there. But these are just some places that you can go see C and C++ libraries. So if you want to write your own, and we're going to start there, most languages allow them to be written, and they contain basically three parts. They've got the header, and then they've got the body, and then they've got the return. Well, we've seen that before. That's really what a full program looks like. But have you ever thought about a C++ program and its name? It's called the main function. This is an example of a main module, and you can see it goes down just so far. You'll notice when we are in line 13, it says set total equals sum first age, comma, second age. I don't remember seeing a sum in there as a word that would actually result in an action. So look down then to line 21, and what you're going to see is a function integer name sum. And it's going to take two parameters. It's going to take, or two arguments. It's going to take the integer num1 and integer num2, and it's going to add them those two together, and it's going to send it back up. So at that point, the line 13 says, set total equal to jump down to line 21. Take two numbers with you, first age and second age, add them together, and then come back up here and stuff it into the variable total. And then in line 16, we actually display together you are total, whatever that was, years old. Now, when we write our own functions, there's some concerns that we need to realize, and that is that many arguments are passed from a program to its different modules. Functions simplify the code. That's really good. They increase the speed at which it can be developed. They also increase the facility of teamwork. Each function should be flowcharted separately, and you should have an IPO for a function just like you have it for a program. So this might be an IPO chart for a little function that you write called getRegularPrice. So it's got input, processing, and output. Of course, we start with the output when we actually write this. So we go output, input, and then process. What about those library of functions out there? What do they have in them? Well, let's just kind of take a look at them. We've got some with mathematical functions, and they're functions that accept one or more values as arguments and then perform a mathematical operation on them and usually return the assets. So here's the one we were talking about. Set result equal square root 16. And so it will return a value of the square root of 16. Now, the nice thing is we have others in there that says set power for 2, so that's going to raise the value of 4 to the second power. You see how that works with those little arguments going in there? It's really kind of cool, and it makes it so easy. Some others might be, other mathematical functions might be ABS, which is absolute, calculates the absolute value of a number. COS may return the cosine of an argument. Oh no, now we're getting cool. Round rounds to the nearest integer. Use that a lot. Sin is not what you go out and do. It's actually returns the sign of an argument. Tan is not a booth. It's actually returns the tangent of an argument. You may have data conversion type functions that actually do something to the data. So toInteger converts a real to an integer. Okay, how would I do that? Well, I'm just going to lop off all the decimal points. ToReal converts an integer to a real. You may have real numbers that can be stored as integers. You have integers cannot be restored as real numbers. Don't forget that. Now, the interesting thing is you can have formatting, and this is really kind of cool, and you see these in databases all the time. You have currency format, which will be actually used to format a number into a currency display. So at that point, you know, when we store a number, we store just the number. We don't store commas or periods or dollar signs or pound signs or anything else. We just store a number. And then we can convert that into the format that we want with the currency formatting. So you can say declare real amount, and there's our float or our real number, and if we actually display it as a currency, then it would be something like that. Cool. We use a lot of the libraries on string functions. String functions are things that we're going to work with that are just letters. So for example, the length function returns a certain length of it. An append may add letters to the end of a field. To upper and to lower are used all the time to convert a string to upper or lower case. Oftentimes you'll just convert the first letter. You have a substring which can extract characters or a portion of a string out of a string. So for example, if someone puts first name, middle name, last name, title, if you looked at the end of that string, you'd find the title, but you may not want to do that. If they don't have a middle name, they put first name, last name, then you may want to be able to realize that second piece of data is actually a last name, not a middle name. So we can do that with those string functions. It can contain similar identities within two strings. It can compare them. So you can say, okay, change the string to an integer and an integer to the real, or the string to the real, which converts what's stored in there to a number. So is integer and is real are also tests to see if they've actually put a number in there rather than text. So if someone goes in and says, I think I want to make the price of this $4, and they put a dollar sign and a 4. Oh, okay, now is real or is integer is going to be one of those things that tests to see if it's just a number. If it's not just a number, then we need to go look at it. Okay, you ready for your checkpoint? Turn to page 269 and do the algorithm workbench, problems 1 and 2, and go ahead and stop the video. And when you get those two done, then come on back and we may have a surprise for you. Surprise, surprise! Here are the answers.